Hello everyone, welcome back to this lectures. So in this video we will going to learn about memory management. So in this is our second video on Rust. So now let's start. So Rust has a very new concept, ownership and borrowing. So before going to these concepts, let's understand how memory management done by other languages. So in all traditional languages, if you see, we have a concept of a garbage collector. So before going to garbage collector, let's understand what is a stack and what is the heap. So if you see in a Java, when you declare any primitive type of a variables, right? So those primitive type of variable will going to store on the stack. But when we have a reference type of a data, for example, if you have a object of any type of a class like a student, customers, right? So those object will going to be stored on the heap, and on stack we will going to have the pointer for those objects. So now come to the garbage collector. So now let's understand the scenario. So in Java, how Java will going to be free that memory, because like if we allocated memory for the objects, so at a one time we also need that memory back. So because if we don't start taking the memories back, so with the time we will going to run out of the memories. So for resolving this concept in Java, we have a garbage collector. So when we declare any object, so if there is no a live any reference to that object, so garbage collector will going to remove those objects from the heap. So this is how Java deal with memory deallocations and assigning that memory again to the allocator. But in stack has a very new concept of ownership and borrowing. So now let's understand ownership. What does it mean? Because in Rust, if you see, we have no garbage collector. So for example, so in Rust, if you define any string, and in previous lectures we know that string will going to be stored on the heap. So this xyz will going to be stored on a heap, right? So like in Rust we don't have no garbage collector, but in Rust, if this name will going to be out of a scope, for example, if I define this name in this scope, so when we going to hit this last curly bracket at line number 5, so this name will not going to available after that. So at that point, Rust will going to be called this drop function to deallocating the memory which is assigned to name variables, and this memory will again going to be used by the allocator for future assignment. So this is how Rust deal with this. So now it will going to create so many things, right? Because it is not, it looks very simple, okay, it's cool. When any variables goes out of the scopes, we can call the function drop and we can release that memory. But this is not that much simple, because in the life of any functions we will going to assign that data to another variable, we will going to pass that data to the functions, and we will going to receive some data from the function. So right, this moving of, if you visualize this flow of a data, right? So this flow of a data will going to create a lots of a problem. For dealing this problem, Rust has the concept of ownership and borrowing. So now let's understand. For example, let me take this. Yeah. So I want to have another variable name 1, and I want to have the same value. So what will going to be happen now? So in Java world, if you visualize this thing, so in Java we will going to have xyz store on the heap, and on the stack I will going to have the two pointer. Name will going to point the same memory, and name 1 will also going to point to the same variable, same memory. In case in a name, if I change that value, right? So in Java, you can just visualize this some object or maybe some array. So both in case of any objects, any array, right? So both pointer will going to point to the same memory. So one pointer will change anything, that data will going to reflect on the another pointer. And when we don't have any live pointer to any data, at that time garbage collector will going to mark that memory for deallocation. But in stack, what in Rust, if you see these things, how Rust Is rust is going to do in the same way, or rust has a some different meaning? Because now if you see these things, name one will going to have the same memory, and name will also going to have the same memory, right? So what will going to be happen, like when we going to hit this scope line number 9, are we going to call the drop function two time for the name and name one? And how rust will going to be handle this thing? So let's visualize first. So if you see on the heap side, we will going to have this xyz like this, and just assume we got some initial address 101, and on the stack we will going to have some this we will going to have some data, for example pointer and length of that data and capacity, like in a byte, how many byte we have allocated for that memory. For now just forget about len and capacity, just assume pointer will going to point this base address of this data. So when we going to assign another variable like a name one, so how what will going to be happen? Just assume if rust copy the same memory again and just assign that memory initial address to name one. So if we going to follow this type of a allocation, like this type of a copying, right? So this will going to be very expensive, because on heap we generally store lots of a data, right? And copying this whole data, it is just like, if you see, it's like a deep copying, right? It's not a shallow copy. So it's a deep copying. Doing the deep copy, it will going to create a huge problem. It will not going to be time efficient. It will going to take us so much time, and it will going to slow down the rust. But abc rust is not slow, so it means rust is not following this thing. So now let's move to the second option. So in second option, if we see, so we have a data on the heap. So if we point name one and name to the same data, so will it not going to be work? It will going to be work, and most of the languages follow the same thing. In Java we will going to follow the same things, right? But here if we see, rust doesn't follow this thing. This has some issue in rust environment. The way they write the rust compiler will going to create some issue. So just assume, so when we going to hit the last scope statement in name and name one, so both name and name one will going to call the drop function, which is called by the rust, and both will going to deallocate the same memory. So it will going to create some problem, because it is not like a good, like a two time we are trying to deallocate the same memory. So this is also has some issue. So how rust dealing with this issue? So in a rust, like when we create a name, and name has some xyz value, and when we assign this name value to the name one, right? So at that time, this name previous variable will going to be marked as a invalid, and this concept is known as the move operation in rust. So now let's see this in action. I will going to explain a little bit more about this action also. So now what I'm saying, if we try to print, at this point, if I try to print this name, it will not going to be available. If you read the arrow, borrow of moved value name, value borrowed here after move. So let's run it. Just ignore this linting error, and if we try to run cargo run, so if we run this, so now let's read this error. It is saying, if this is intentional, prefix it with, okay, it's just unused. So okay, from here just read it. So it's saying move occur because of name has type string, which does not implement copy trait. We will see what is copy trait. And name one equals to name. This is we are doing assignment. So basically rust is saying here move operation is happen. Whatever the memory which is pointed by this name, now that memory is moved to the name one, and now this name is invalid. It cannot be used because it is not pointing to anything. So here if you see value borrowed here after move, so once the value is moved, after that we cannot use that variable. So now let's see, just ignore this clone or this, it is just suggestion by Rust. If it is intentional, then we can use clone. We need both reference as a valid. So this is very interesting. So what will going to be happen? So this name is pointing to some memory in heap. When we assign this name one, when we assign this name one from the value of name, so this name one will going to be will going to have a valid pointing to this memory, and this name reference will going to be marked as invalid, and this operation is called as like a move, like a moving the ownership. So here in Rust, now let's introduce this ownership concept. So in a Rust, we have a ownership concept, and generally this concept will going to apply only for the data which is stored on the heap, because if data is on the stack, so copying from the stack will not going to take any time. It's a very easy operation. So let me show you. So all the primitive type we already learned will going to be stored on. Okay, so here I have 32 integers, right? So if I try to create another variable, and if I assign this integer, and after that if I try to print both, let's see both has a data or not. Okay, so now let's run this. So now if we see, both has the valid values. So what is happen here? So it was failing for here, but it is not failing for here. So for now, general rules, like you can assume all the value which is being stored on a stack, those value will going to be copied. So there is a concept of a trait. So for now you can just ignore this trait. If you are coming from a Scala side, then Scala is also has a trait. So for now just forget about this and just assume in Rust there is a one functionality, for example like a copy. You can assume this some kind of a interface. You can assume, if you are coming from a functional languages, you can assume it's some type of a type class. Okay, so if any implementation, right, it is implementing that trait, right, so those will going to be copied. So for example, all the primitive type is implementing copy trait. So whenever we will going to assign in all the primitive type, float, integers, char, and even a tuple, if tuple is containing all the primitive type, so all those value will going to be copied. But in case of a heap, when we going to when we are storing the value on the heap, those value will not going to be copied. If we want to copy, then we have to implement the trait, copy trait for that particular type. So basic thumb rule, for now you can just learn all the primitive type implementing copy trait, that's why their value is copied. Or in other word, another word, you can just also like understand all the values which is stored on the stack, all those value will going to be copied. All the value which is being stored on the heap will not going to be copied until and unless that type is not that type is implementing copy trait. So now let's move further. Let's come back again to our this concept. So now we have learned about a move operation. So in Rust, you can just learn a new concept. Just make generally like a Rust has three rules for ownership. Just forget about three rules. I will just help you to visualize. So now in Rust, you can just learn, if we are creating any value and which is being stored on the heap side, so that value will only going to be pointed by a one reference. So it means every value will going to be have a one owner at a time. So for now we create xyz, and the ownership of this value is to name. After that, when we assign this name to the name1, ownership is moved to the name1. Now name1 has the ownership of this xyz and name is invalid. I hope it's clear for you. So now let's see few more example. So now let's move to the function and we will see how ownership work in function. So if you are still confused about the ownership, so just assume when we create any data on the heap, so that data will only going to be referred by only one variable. That thing is known as the ownership. So when we assign that that variables to another variable, so this operation is known as like a taking the ownership, like a moving the ownership. So now name1 has that ownership. So now let's see in function how it's work. Take ownership, sorry, it's not Kotlin. So here we want to take a variable. So here let's print this. So we created a very simple function. That functions take some string and print that string. Very simple. So now if I try to use this function and if I try to pass this name, so now let's delete this. So how this thing will going to be happen? So now let's run this. It will going to be work or not? So it is working. So now you can just validate your concept again. So we created xyz on the heap and the ownership of this data is with the name variable, and now we pass this name to this function. So now we have another variable some string. Some string is pointing to the same variable, right? And we know that when we do the assignment, like passing as an argument is also like assignment. So what will going to happen with this name if I try to use after passing this data to the function? So now let's see. It will going to be fail. It's again the same issue. So it is saying we have passed the ownership of this name to this function and after that we cannot use it. If we want to get this ownership back, right? So we can do one thing here. So now let's return this some string and we will write like this and we can take this ownership again. And now we will able to use. And we know that we can define the same name again and again in Rust. There is no issue. So now if you see, we are able to print that value xyz. So this concept is like giving the ownership and we can take the ownership, but is very time consuming, right? And is also it's not good. Like just assume like this function is doing something and this function every time has to return that variable. So in some time, like if you are working on any application, you just want to read, you just want to do some computations. For example, you got customer data and just you want to evaluate what in what category this customer is face, and you want to run some validation or something. You don't want to mutate that data, right? So sometime you just want to use like a read only. So at that time, if you see like we need to follow the same thing, like taking the ownership. Now we got that value completely and now we need to move that value again in a outer space, otherwise this value will going to be deleted after this. That was the reason, like if I don't take this value again. So now let's run this. Okay, it will going to be fail because at this point this value will going to be this value will going to be deallocated and we are not taking this value here, right? So after that there is no name is exist, this reference is invalid because Rust give us the guarantee if we able to compile, then every reference and everything will going to be valid. At the compile time it will going to pick all those actions which can lead to a invalid reference. So let's move this. So now what we can do instead of doing like a taking the value and again returning the value. So for resolving this issue, Rust has another concept, borrowing. So now we understand what is ownership. So ownership is very simple. At a time, one value can be belong to one reference. Only at a time one owner will going to have for one value. So if we want to move that value to another function, that will going to be like complete move for now, because we don't know about the borrowing concept. Okay, so now let's move to borrowing concept. So let's delete this, and now let's write another function. So here we want to receive some string. Okay, and here we want to print this string only. So here we don't want to take ownership, we just want to use the data, and after that we want to whatever the life cycle, whatever in scope that variable is declared, just follow that scope. We don't want to take any ownership. So there is a concept, borrowing. So how borrowing will going to be happen? So here we need to use ampersand sign. So it's mean whatever the string type we will going to give this as an argument to this function. So this function will only going to take borrowing. It will only going to read that data. It will not going to take any ownership of that data. So now let's try to call this function and see how it will going to be behave. So if I pass our name variable, so at a regular, like in regular we used to pass like this. We know that if we pass like this, it will going to call that a move operation. But here we want to pass only reference. We want to take the ownership to this name, and we just want to pass the reference for using. So here we also need to use ampersand, something like that. So when we use ampersand, it's mean we are just this function is just borrowing the value. This function will not going to take ownership. So basically if you visualize this thing, so this is like this. On the heap we will going to have this value xyz, and this xyz is owned by this name variable. And when we borrow this name, when we borrow this value, so we will only going to have the pointer to this stack. We will not going to take ownership, and we will not going to copy len and capacity, all these things. In move operation we used to copy, but in borrowing concept we will only going to have the pointer to that value. So now I hope it's clear for you. So now if I try to call, let's run this, and it will going to be work as it is. Here I have not take that value again to the name. If you see, this name is still a valid, because this name is still taking the ownership of this xyz value, and here we just give to this value to this function, and this concept is known as borrowing. So now let's move further on the same line. So let's remove this, and now just assume we have a function, so which will going to update the value whatever we are receiving here. So here we want to use this function update name, but here if you see, we want to use this name update, sorry, update name function, but we also want to use the name after calling of this function. We don't want to give the ownership to this function. So we know that borrowing concept, so it's very easy. So now let's give this, change to ampersand sign, and now we know that this update function has is borrowing this name this variables, and now this update functions can do whatever that function wants to do, and after that we will able to use that name. So now let's see, if I try to update this name dot push string abc, see, it will going to say this name is like a borrowing, so we cannot mutate this. If we want to mutate, then we need a reference which is type of a mutable reference. So what is this mutable reference? So now if I do like this, mu2, so this reference will going to say that when I'm going to use this mu2, right, it is saying we are borrowing this value, we are not taking any ownership of this value, but we want to mutate this value. You got it, right? So it basically is saying we will going to change this name value, but we are not taking ownership. So now let's define this also. So now if you run this, so it will going to be work as expected. So here basically we are saying we are taking mutation type of a reference and we will going to mutate, and we are just borrowing. So this thing will going to lead so many problem. Now just assume I have another function, and this function also wants to take a mutable reference to the same value. So if I define this function, now let's define this quickly. So now if we see, we have update name function, we have another function, and both function wants to update the value. So now let's see it will going to work or not. So it's working. So why it is working? So maybe you are confused, like you will be thinking, okay, we take this mutation ownership to this function, so now this function should not take mutation ownership. But if we see, we pass this mutation reference to this function, and this function will going to mutate, and after this scope will going to be end, and after this scope we are using this value, right? The same thing if I want to do, for example, so here if you see, like this mutation reference got created and also dropped before creating this another mutation reference. So if I try to create, so let's create, so we created one mutation reference, and now let's create another mutation reference to the same value, sorry. So this is another mutation reference, and now instead of passing this, pass like this. Okay, so it will going to create the problem. So it's saying cannot borrow name as a mutable more than once at a time. Second mutable borrow occur here. So basically it's saying once we create a mutable reference, so within the life of this mutable reference, we cannot have another mutable reference on the same scope. If I want to declare another, just for example, if I have something like that, okay, it will going to be work, because in this scope we create a mutable reference, and when we going to create this mutable reference, at that time this reference will going to be dropped. But here in the same scope we have created two mutable reference, so this will not going to allow by the rust, because at a time we have a two reference which can change the same value. So it will going to lead in the problem, because we don't know, like at a time, like for example, like if it is running on async, right? So those thread have the same reference, mutable reference, and those thread will going to be changed, so it will going to lead in inconsistency. We don't know what will going to be happen. So rust has a rule, at a time we will only going to have a one mutable reference, not a two mutable reference within the same scope. So now let's see, if I try to, if I try to create just a reference, immutable reference like this, so I can create as much as I want. So there is a so I hope it's clear for you. At a time we can have one mutable reference, or we can have n number of immutable reference, as much as we want. So I hope this concept is clear to you. So I try my best to explain this ownership and borrowing. I hope it's clear for you. In next video we will going to learn about a slash type. So if you like this video, please like and subscribe. Thank you.